Welcome to Terrible Lizards, a podcast about dinosaurs with Dr. David Hone and Izzy Lawrence.
Hello and welcome to this episode 2 of series 10 of Terrible Lizards. And you'll be pleased to know, Dave, that in the previous episode I thought I did a really sneaky thing. So I think I said it was like series 12 or something. And what I did, and I got that wrong. It's because the last episode we did was episode 12, and I thought, oh, it must be 12 because numbers. Anyway, so I said that, and I thought, I know, I'll just do a really nice cover over it. And on my headphones, it sounded absolutely fine, and it sounded like Izzy so say series 12, but in fact, it went series 12 like that, and series 12. Like that, and I just sounded ridiculous. So,
Why would you cover over the incorrect series 12 by saying series 12 again?
Oh yeah, that's a good point. I'm not very good at this, am I? I'm a really bad liar. Damn. Oh well.
Anyway,
we don't need to lie in this episode because we barely need to speak at all because we have a guest.
Yes, which makes a pleasant change, so I don't have to think of something to say. Hopefully coming for the rest of this series, more Dave not talking. So if you have suffered with us through 10 series, you can finally look forward to some episodes which don't contain Dave.
People like you talking. They particularly like it when me and all the guests winds you up. I don't know what it is. There's something about it. I believe in if I can get away with saying flappy flap, I will. So, that I'm just saying.
If you didn't.
I know, but it's your podcast and I have to ruin it for you.
Have to is such a strong phrase. Anyway, I feel this introduction is dragging on far more than we ever intended it to.
Indeed.
So hopefully we've got a few interviews or discussions, let's say, for the upcoming episodes on this series. But we wanted to start with Skye McDavid, who has definitely been mentioned more than once before, and is in general a scientific illustrator, which is kind of different to a paleo artist. We've had paleo artists on who draw animals and plants and environments as they were, whereas this is more about, bones and structure and fossils and the actual physical items that we work with is what she primarily does, but also is an independent researcher, so has published a number of, and in particular, she's doing quite a lot of stuff on Coelophysis, which is one of those really interesting little animals that we've mentioned loads of times, but I don't know that much about, and it's quite complicated. So getting someone in who can do the stuff that I can't do, really, really useful. So that's why we asked her on, and she said yes.
Brilliant. Well, here is that interview. So we now have a very special guest, as I've previously introduced. Dave, why don't you do the formal introduction as to who is this person? Why are they on our podcast? What's going on?
This is Skye McDavid, who we've definitely mentioned before because she was very kind enough to do all the illustrations for my pterosaur sternum paper that we did talk about last year when it came out. And she did some of the illustrations for the petrodactyl paper, which we talked about when it came out, but also is an independent researcher in her own right and has written a bunch of papers on various dinosaur bits and nomenclatural acts, which is always really, really important stuff, but in particular has focused on Coelophysis. And since Coelophysis is a really, really interesting dinosaur and one of those things that I know almost nothing about, even though it's really interesting and important, is the sort of thing we should have covered years ago. We're going to cover it now thanks to someone else being able to talk about it when I can't.
I promise I know less than you, Dave. So all I know about Coelophysis is it's really old.
It is really old. It is not quite the oldest dinosaur. So it is from the Eurasian stage of the late Triassic.
Eurasian?
Yes. That is like 205-ish million years ago. So the oldest dinosaurs were a little bit older, maybe 220 to 230 million years ago. But this is still the very beginning of the dinosaur age. And while you still have lots of crocodile archosaurs, including some that really look like dinosaurs but aren't dinosaurs running around before the Triassic-Jurassic extinction.
Okay.
So yes, they are very old. And it's kind of the oldest thing that really looks like a theropod.
Okay, so it's on two legs, bipedal.
Yes.
And it's got snappy teeth, I'm assuming, pointy teeth
and
carnivorous.
Claws,
yes.
Yes.
And so what's it doing around there? Why aren't there more of it? What do we know? What don't we know? Tell me things.
Well, we know a lot, but we also don't know that much. Coelophysis has a complicated history. Most dinosaurs are only known from one specimen, maybe two specimens if you're lucky. You have things like Velociraptor, where you have like maybe 12 specimens of Velociraptor sensulato.
Have we got that many? Sorry to cut you off already. I know about 4 or 5. It's like, are there really a dozen?
Yes.
Okay. Is the AMH holding them all?
Yeah, but yes, there are 12-ish specimens of Velociraptor sensulato. There are, if you look at some of things like Confuciusornis, there are a couple hundred specimens. And then Coelophysis, it has been estimated there are over 1,000 specimens.
Whoa!
Or 1,000 individuals.
But that's the oldest. Surely you'd have fewer of stuff that's further in the past. That would make more sense, wouldn't it?
That would make sense, but that's not what happened in reality. Because by a quirk of geology, there is this one bone bed in New Mexico at a site called Ghost Ranch, which was actually once an actual ranch owned by Georgia O'Keeffe.
Amazing.
So if you've studied art and heard about Ghost Ranch, yes, that is that Ghost Ranch. Georgia O'Keeffe was there supervising the fossil excavations under Edwin Colbert of the American Museum of Natural History, whom I'll probably talk about later. And so there is this one bone bed where we have hundreds and hundreds of individuals of Coelophysis, but they're all disarticulated or semi-articulated and badly jumbled. A lot of them are damaged. It's not always clear what you're looking at. So there is this wealth of data that you could potentially get, but it is sort of understudied.
Because it's hard.
It's difficult to work with. Right.
Yeah. My understanding as well was that the rock is relatively tough and that this is something which is slow to prepare and therefore the usual problems that we've talked about, it takes a lot of time, therefore it takes a lot of money. And when you've already got 50 out of them, yeah, the paleontologist in me goes, yes, I want 100, I want 200, I want 500. But people are sitting around going, yeah, and that's another couple of decades' work. And we're not going to do that.
And that's why some of the Coelophysis blocks that were collected in the 1940s have not been prepared. I mean, the Carnegie Museum supposedly has stuff from the Bone Wars that has still not been unpacked. Bone Wars is late 19th century. So Coelophysis, it has been estimated that there are over 1,000 specimens, but there are not that many that are really usable, and a lot of them have missing data. And of course, the best specimen is behind glass, so it's inaccessible in a different way.
Is that the Los Angeles one, or is there...
No, it's the Neotype in New York.
Oh, yeah, okay.
AMNH Farb 7224 for those keeping track.
Nice.
It's a beautiful specimen, complete, articulated, and well-preserved, but behind glass.
I mean, I think this is a great example of that. So when I did, years and years ago, I did a paper on body size distributions in dinosaurs, and my colleague was not a paleontologist, was helping me with this. And he said, right, we also need to do a look at intraspecific variation so that we can look at, you know, how good the data is that we've got for all dinosaurs, because, again, most of them are based on one or two things. So I went, okay, how many do you need? He's like, as many as you could get. So I went away, and Coelophysis was the obvious one, because there's so many of them. And yeah, Colbert, who Skye just mentioned, had done this monograph on it, so I trolled Colbert's thing, and then a whole bunch of other papers. And I came back, and I went, here you go, Owen, I've got like 40 specimens. And he's like, that's rubbish, I thought you were going to get at least 100. And I'm like, no, this is the best data set in the world. I don't think a data set of this many dinosaurs has ever been published by anyone before. And it's half what you want. This is how annoying and bad dinosaur data sets are. Where actually Coelophysis is still incredibly valuable, whilst being nothing like as good as it could potentially be if we threw a few $1 million at it.
Exactly. So Coelophysis is incredibly useful for intraspecific variation studies and for ontogenetic studies.
What are those things for people who are not biologists?
Oh, yes. So intraspecific is within the same species.
Nice.
So how they differ in between individuals of the same species. And ontogeny is how it changes during growth.
So you can get a really good understanding of how the babies changed into adults, and you can get an idea of maybe sexual dimorphism, if that's possible to calculate with this.
All that sort of stuff, yes.
Yeah, so actually it had been proposed that Coelophysis was sexually dimorphic, sort of hinted at by Colbert. Greg Paul wrote about that a bit, and he was wrong because the morphs that he identified as the gracile morph is actually just less mature than the so-called robust morph, that it's just an older individual. So that is a hypothesis, and then with ontogenetic sequence analysis, which is just very fancy math, basically.
I think percentages are quite fancy, though. That's about the limit of my statistical ability.
Ontogenetic sequence analysis. It's a fancy technique that I'm trying to do, but it was used by Chris Griffin and Sterling Nesbitt to basically prove there is an enormous degree of intraspecific variation in this species, but no sexual dimorphism. Because sexual dimorphism would show two distinct patterns, whereas Coelophysis is just all over the place.
That's really cool, but actually at some level not too surprising, because I know the Germans, it was almost certainly mine Sanders group, did an analysis of Plateosaurus, so very, very common prosauropod from the Triassic of Germany, and found the exact same thing, where actually you've got this greater degree of plasticity. So in other words, humans, despite our variation, we grow at a fairly consistent rate, and it is rare that you will have a 15-year-old shorter than a 10-year-old or a 20-year-old shorter than a 15-year-old. And actually, early dinosaurs in multiple different lineages don't seem to have this pattern. They do settle down, but the early dinosaurs seem to grow not at random, but way more varied than you'd think, and therefore you can have absolute monster individuals, which are actually really quite young, and relatively small adults, relatively small animals that are old adults, and really not the pattern that you'd expect for anything else. So this is the Triassic dinosaur thing that later on they sorted out.
I mean, you see that in some early Jurassic sauropodomorphs too, but that is very much the case with Triassic dinosaurs.
Yeah, it's not in sauropods proper that I know of. It's not in any of the later theropods that I know of. It's not in any of the ornithischians that I know of. It just seems to be these Triassic, and older ones just have this madness about how they grew.
Is that to do with the fact that they just grow when there's food?
Pretty much. That is the hypothesis.
So they get access to stuff and they get really big and fat and shoot up.
And the Coelophysis population, they're almost all partially developed. They're not old adults. There are some that are maybe nearing full maturity adulthood. I have yet to find one that I can consider an old adult based on morphology. There are some people who have done histological studies based on isolated bits. I have not been able to find a sort of old adult skull yet.
So what on earth is this bed? Is it some sort of predator trap? Why would you have all of these, specifically this species of dinosaur, all in the same place, all jumbled up? Why?
So it is, the leading hypothesis is that the animals died in a drought. And then they all ended up getting carried to this one spot by a river. And that's why they're jumbled up. Some of them have burst.
That's not a good word.
Like you've seen I'm sure you've all seen this video of the whale that gets cut open and the guts explode all over the place.
Yeah.
That happened to a Coelophysis.
There's an excellent one of it happening to a lion as well, when he's trying to eat a very old hippo and it explodes on the lion, which is particularly humorous.
Fantastic. But yes, there is evidence of that happening to a Coelophysis, and then having more random stuff shoved into its body cavity by the river.
Okay. So that I didn't know, and that's something I'd always wondered about, because the conventional reconstruction of this is the forest full of Coelophysis. And this is a classic example of, look, they lived in big groups because we found a big group together, which then, once you dig down into the details of the history of this specimen, it's like, well, maybe that was true, but equally, they're probably going to be forced together when there's a limited water source.
Exactly.
And of course, the other thing is, because this is also worth asking you, which is not coelophysis, but is very much coelophysis-centric, they're not the only thing there, are they?
No. So the coelophysis quarry is very much dominated by coelophysis. I hate using that word because whatever, but it is like 90% of what is in that sample is coelophysis. There is one other dinosaur that was found there, Demonosaurus, which is
Nice.
a skull and cervical series neck vertebrae of a dinosaur that is actually quite fascinating in its own right because it is a baby, but it's quite large. It's larger than coelophysis.
How big are coelophysis actually? I need to picture them in my head a bit more.
They're like 2 meters long.
Okay, so they're quite small dinosaurs. And 2 meters long, that's nose to tail.
Yes.
So we should have said, actually, for a very early dinosaur, they're pretty typical.
Yeah.
But compared to kind of like stock theropods, they're not. So the head is actually quite small. The neck is really kind of long.
Yeah.
And they're pretty small, lightly built animals overall. So, Allosaurus is always like my go-to.
Yes.
This is like the basic form of theropod. Though, of course, it's not, because Allosaurus is really quite derived. It's late Jurassic.
Right.
But yeah, coelophysis and the coelophysoids, they really are skinny little necky things, and really not like, I would argue we don't really see anything quite like them again until you get to like the really derived dromaeosaurs almost, where you've got something this small with a relatively little head and long arms. So you've gone through this entire transition of coelophysis into allosaurs, spinosaurs, tyrannosaurs, carcharodontosaurs, and then all the weird near-bird stuff. And then finally, at the other end, we start producing something coelophysis again, 150 million years later.
I agree with that. They really do. The most similar thing to coelophysoids, other than other basal theropods, would be sort of these late Cretaceous smallish dromaeosaurs.
And that small head, actually, to touch on that small head is odd too, because once you get past the coelophysoids, you're already into things like Dilophosaurus, which everyone's familiar with because of Jurassic Park. It doesn't look like that. It was much, much bigger, but it has a good-sized head on it. Like a Dilophosaurus skull is a big, solid thing on a relatively long neck, but it's a big, solid head. Whereas coelophysis, it could pass for a deformed, toothy swan on the head and neck front. The head is really quite small compared to that great big long neck, which is very thin. So they have got a very distinctive profile.
Other interesting thing that you find in the coelophysis quarry is Ephegia, which is not a dinosaur. It looks like a dinosaur. It is a poposauroid pseudosuchian. It's a crocline archosaur that looks like an ornithomimosaur, basically. Super convergent with ornithomimosaurs. They have toothless beaks and everything, but they're not. They're distantly related, more closely related to crocodiles.
Okay, so I'm thinking of a crocodile that looks like a duck.
That looks like an ostrich. This is bipedal, with a small head, a beak, and a long neck. So ornithomimosaurs, the bird mimics because they already look ostrich-like. They've just got a long tail and bigger arms. Ephegia, as I call it, I don't know whose pronunciation is right. Ephegia?
I say Ephegia.
Ephegia. Okay. It's what I've only ever seen it written down.
I think Sterling says it a little closer to how you say it.
Oh, does he? Okay. So, yes, it was named by Sterling Nesbitt,
yes.
who you mentioned before when he was working at the American Museum of Natural History.
You say Ephegia.
I say Ephegia. Yes. So, imagine an ostrich with a much longer tail and relatively short legs, so they don't have the legginess of ostriches or ornithomimosaurs. But yet, it's a bloody bipedal herbivorous crocodile. It's not. That's ultimately what it is, or at least something close to that. They're much more on that side than the dinosaur side. Yeah, that's running around then as well, and that's come out of the quarry. So it is not just coelophysis. They dominate, yes, but there's other things in there, including relatively big herbivores.
And so, what do we think this happened? There's been a drought. Everything's gathering at the river, and then they all die because the river dries up, and then they get washed away? Or is there a massive storm surge, and they all get washed into the same thing? They all die together, and it's really exciting.
Possibly one or the other. I don't know.
I'll go with the dramatic one.
I'm not a taphonomist, So
I love the fact that this is the first time I'm hearing the word taphonomy.
Taphonomy. We've talked about taphonomy. So taphonomy is basically everything from the moment the animal dies to the moment we dig it out of the ground.
right.
Okay.
So lots of things can happen to it between those two, which will mean that the fossil you have in front of you is not as it was when it died. So the scavengers get to it, the river washes it around, it then gets buried, which means it gets squidged, and then the rocks deform over 100 million years, and then it's partially eroded because the river comes through, or we find it. All of that is taphonomy.
Yes.
Fair enough. Including it exploding.
Yes.
Very much so.
The part about the Coelophysis exploding, I feel like, is interesting in its own right, but it's part of a broader narrative, which is something that's important to talk about when you're talking about Coelophysis, and that is cannibalism. So, in 1989, Edwin Colbert wrote this long monograph about Coelophysis that I have a copy of on my desk somewhere. Has a lot of errors, unfortunately, and a lot of stuff that needs to be corrected. In this monograph, he claims that two specimens, AMNH 7223 and 7224, have remains of juvenile Coelophysis in the body cavity. And he interprets this as evidence of cannibalism of adults on juvenile. And it was later shown through taxonomic studies that one of these specimens had burst open and the stuff inside was just shoved in by the river, basically. The other one had an intact body cavity. It had gastralia, the belly ribs that some reptiles have, including most dinosaurs. And there were bones inside, nothing that could be identified as Coelophysis. There was just one femoral head that was probably Hesperosuchus, which is a sort of, imagine a crocodile that wants to be a fox.
Just the top of the thigh bone. That's all that's in there. Okay.
Yeah.
So these two specimens do not show any evidence of cannibalism.
So that's a myth that's kind of been put to bed, or I mean, is it doesn't seem too unlikely that there would be some form of cannibalism, just because it's surely some members of the population, particularly if there's a drought or if there's
So you don't
pressures.
have evidence of cannibalism in these specimens. There is another specimen that has been interpreted as possibly being evidence of cannibalism. I don't think there is good evidence of cannibalism. There isn't good evidence of absence of cannibalism either.
We can never prove absence of cannibalism. That's the issue. Absence of everything is hard to prove.
Very, very true. So yeah, I mean, it is something you might expect to turn up. So, I know it turns up in Tuatara. I know it turns up in various crocodiles today. And then Tyrannosaurs, T-Rex definitely. We've got evidence of cannibalism, of just eating bodies. And then I think it's Majungasaurus, the Abelisaur in Madagascar, has got remains of juveniles in an intact body cavity that we're pretty confident is real cannibalism. And again, if the kind of scenarios we're describing of some kind of drought forcing things together, carnivores are probably going to chew on the bodies of juveniles that are there.
Absolutely.
If there's any kind of moisture left in the muscle tissue. You might have little enough water that you're dead. That doesn't mean you've got naught water in you, and therefore you're probably worth eating a bit of. So I can easily imagine it went on, but yeah, can we demonstrate that is a far harder proposition.
I am definitely not saying that Coelophysis is not a cannibal, but that there is no evidence of it in the two specimens that were claimed by Colbert to be cannibals. This monograph causes me pain because of how many mistakes are in it.
He was getting on there, wasn't he?
Yes.
It came out in 1989, because Colbert wrote, was it the book Men and Dinosaurs, which I think is from like the 50s or 60s, which is a real kind of classic piece of pop culture writing, not pop culture, that's, popular science writing of its time. And I think it was like the big book. I got hold of a copy relatively recently and read it, and it's genuinely excellent. I mean, it's an interesting read now because of the history, but I can imagine that when it came out, and I think it is something like late 50s, this is groundbreaking stuff for a group which were just, dinosaurs were always popular. It doesn't mean there was material available for them.
Yeah.
I'm just trying to do the maths. It's like, I thought that was towards the end of his career. So if he's writing in 89, How old was he? Surely he'd retired by then.
So he had retired from the American Museum of Natural History, but was working part-time at the Museum of Northern Arizona.
I just looked it up. So born 1905 and died 2001, age 96. So yeah, he would have been nearly 80 in 89.
And in general, when it comes to Colbert, he has a lot of work on mammals, which I am not qualified to evaluate. He has work on continental drift with Listersaurus in Antarctica. That is what makes him famous. And he helped prove plate tectonics with Listersaurus. And that is very significant. His work on reptiles is often disappointing.
But still, plate tectonics under your belt, it's not bad. It's just upsetting for you because all of these myths go around about a particular dinosaur that isn't entirely true.
Yeah, and there's one specimen where he gives an orbit to skull ratio. The posterior border of the orbit is displaced, so it's impossible to accurately measure the orbit, and the premaxilla is displaced, so it's impossible to measure the premaxilla to quadrate skull length. So he just has this ratio of two numbers, neither of which actually can be physically measured on the specimen. So I have no idea where either of the numbers came from, and that is not an isolated occurrence.
No, this sounds a lot like my science GCSEs. This is great. That's what I would do.
Well, I would say none of us are perfect. I'm sure my data sets are not always 100%, but and I think even the best work you find errors. But if you start finding repeated ones, it's generally
when you can't measure something and you're giving a ratio between two measurements you don't have. I think that's brave. We'll put that down as bravery.
Yes, the osteological data in Colbert's monograph is not accurate. There was going to be a project to redescribe the cranial osteology, but that has
skull.
been... Yes, the skull.
Just so I'm understanding, I'm a bit slow.
No, cranial osteology would mean a detailed description of the different bones of the skull.
Gotcha.
That kind of got derailed, so it's not clear when that is going to be published, if ever. I have an osteology that is, as of this recording, I am hoping to resubmit very soon because it's been in revisions for 6 months, of 2 juvenile skulls. And so that focuses on ontogeny, but it also sort of corrects the record on a lot of things that were inadequately described previously without really stepping on the toes of this upcoming osteology. So hopefully this should bridge the gap if it does get published soon, which I hope it will.
I believe in you. It will happen.
So going back to what we were saying about growth earlier, so when you say juvenile, are these some of the smallest known skulls, or are these actually quite big, but from very young animals?
So the 2 that are covered in detail in my osteology are sort of midway through growth.
Right.
So they're not the smallest ones. The smallest one is a random jumble of bones in the Royal Ontario Museum. There is one thing that I am pretty sure is a maxilla that has an antorbital fenestra that is like 1 centimeter long.
Oh boy. And that's complete?
That's the complete antorbital fenestra, yeah.
Wow. So you're talking about skull, just trying to do the math,
like
5 or 6 centimeters long? Yeah, so you talk about an animal well under a meter with tail. I mean, that's very
super
small.
tiny.
So, yeah.
That is the smallest one that I am aware of. There's one in the American Museum of Natural History that's a little bit bigger. There is one in the Museum of Northern Arizona that I have not been able to look at yet because it is in Flagstaff, Arizona, which is quite far from where I live on the East Coast. And there is still quite a large sample size. So the 2 that I am looking at primarily are these sort of middle of the growth trajectory, if you want to simplify it down to a single growth trajectory, which...
So when we say middle of the growth trajectory, I'm very human-centric. Are we talking about a human 5-year-old, so they've gone from baby and gone through the toddler section, but they're not yet adult, or are we going to just become an adult but still got a lot of growing
No,
to do?
so we're talking about like a 5 to 7 year old in human terms.
Oh, that's cute. Yeah.
Yeah, they are very cute, very boopable. I have booped the snoots.
That's the scientific term, guys, is boopable. There we go, good. I like that.
And then there's this idea that theropods are these like enormous toxic masculinity creatures that just eat everything in their path. And I'm just this like girl with blue hair is like, small, boop the snoot. It's good. But I still do theropods.
So from my understanding, as we know, as we've discussed in this program, you've got the ornithischians, the saurians. This is on the saurian side.
Yes.
And this is one of the earliest ancestors of the saurian. So am I thinking that right, or have I got that completely wrong?
It is
in my
a
head?
saurian.
It is a saurian, and specifically a theropod.
It's an early saurian. So is it a case that the ancestors of this dinosaur go on to become things like Diplodocus and that sort of thing? Or have they already separated? Where in the family tree are we? Are we looking at the first theropod, or we're looking at one of the first saurians? Is basically my
theropod.
question.
It is a theropod, and it is part of a group called the Coelophysoids, which is named after Coelophysis and includes a bunch of stuff from all over the world that are broadly similar to Coelophysis, and those are the earliest branching group of definitive theropods.
Okay.
There are a couple of things that are maybe theropods, but also maybe not, that are more basal, but the phylogenetic position of those is very uncertain. So the Coelophysoids are like the earliest major group of theropods, but they are well and truly theropods.
And so a species in this group later went on to become the theropods that we're all familiar with. We don't know which one they're directly related to, but there would have been a Coelophysoid type dinosaur that went on, and from there you get T-Rex and you get all of the dinosaurs.
Everything. They're the furthest branch, so yeah.
So all the birds as well then?
Yes.
Yeah.
Cool.
Yeah. If you think about the big family tree, this is you've got your line for the start of theropods. There's a little branch that comes off with a cluster of Coelophysoids, and everything else is on the upper branch.
Exactly.
So they
T-Rex
really
to
are.
blue tits, they're all
Yes.
Literally
Nice.
everything else. So they really are that kind of earliest definitive group. So you mentioned the distribution, Skye. So that's something I was going to talk about because, again, and I want to get the taxonomy side of this, because you've got inverted commas Syntarsus down in South Africa, which was formerly regarded as Coelophysis, I think, if my memory serves me correct, and then it got renamed anyway, and and it all gets horribly mixed up at that point, and I can't remember anything.
Yes. So there is a dinosaur from Zimbabwe, and it was originally named Syntarsus. That name was already taken by a beetle.
It's always beetles.
So many beetles.
Sometimes it's moths, but usually
Yeah.
it's beetles.
Yeah, beetles, moth, and then for vertebrates at least it's usually fish.
But anyway, the name Syntarsus was already taken by a beetle, and then some entomologists renamed it to Megapnosaurus under questionable circumstances that many in the paleontological community viewed as unethical. And so they translated the name as Big Dead Lizard. It actually means big lizard without breath, which I think is kind of a poetic way to say dead, but it's the Big Dead Lizard. And a lot of paleontologists saw that as insulting. And then you have an effort sort of to synonymize it with Coelophysis in order to avoid using the name Megapnosaurus, which means Big Dead Lizard, which had previously been proposed, and subsequent work has shown that they're not sister taxa, and there's quite a bit that separates them morphologically, including my own work has shown that. The paper that I have had in revisions for 6 months now quite literally has in the last paragraph, we retain Megapnosaurus and Coelophysis as separate genera. And I think we can be pretty confident about that. But anyway, people don't like the name, but we have to use it because that is...
No, it works. Yeah.
So where is the distribution of Coelophysis in general then? Are they, because if they're not in Zimbabwe, where else?
New Mexico.
Just New Mexico.
Just New Mexico.
Just that one
this
bed.
one bone bed, yeah.
Weird. And it's just this one event that, oh, wow.
Well, no, but that's your usual problem, is because as Skye said at the start, most things are only known from one specimen, because that's the only place we've ever found it. This is the same problem ultimately, is that...
But in my head, it's the first place we found it, and it's the first specimen, and then we go and we find them everywhere, because we're looking for them.
But if you've only got so many rocks of the exact right age that are available that we can dig in... then even with things like this, I've been to the Centrosaurus bone beds up in Alberta, and there's again hundreds, if not thousands, of animals there, and they turn up in other places, but not many of them, because that one spot is such an incredible one. And so this really isn't a surprise that Coelophysis as a species is currently not very well known. Well, isn't known from anywhere other than one place.
Coelophysoids, however, are known from several continents. We have several others from North America, like Camposaurus.
There's one in China, I think. Yeah.
There is one in China from the Lufeng Formation. It is called Panguraptor.
That's the one.
Sorry, I just like the name.
It's a great name. Yeah. It is a great name. There are a couple in Argentina, Luciano Venator and Powell Venator.
Is there any in Europe? Because we've got some Triassic stuff.
Yes, there are a couple in Europe. There is Procompsognathus or Procompsognathus from Germany.
Yeah, of course.
And there is Pendrake, recently described from Wales.
Oh, yes.
We've got a Welsh one.
Yes.
Yeah.
I'm closer to Wales than Dave is right now, so I feel more connected now to the subjects than he can possibly be.
No, I should have remembered that one, because I was on TV talking about it, where I unfortunately this is what happens when you get an expert on. I'm going to tell this story because it makes me look good. Where you can accidentally cause problems for your colleagues. So they'd announced that they'd found this thing before the paper was out. So I was on a live TV show. I was at home because I was live streaming the video, and so the presenter was like, they put the skeleton up on screen and said like, so we got this amazing new dinosaur, new British dinosaur. It was really, really exciting. And they went, so what do you think? And I went, oh, it's great that we found a coelophysoid, because you could see like the notch in the jaw and the shape of the thing. And I think it was Dave Martell, but I can't remember. There was a paleontologist from either Southampton or Portsmouth who was working on it. So they had, the expert, and then I'm coming in as the independent. And he's like, oh, well, we don't know that yet. And it was clear that they didn't want to say what they thought it was on TV. And it was the first words out of my mouth. Was saying, well, it's obviously a coelophysoid.
Well, Pendrake definitely is a coelophysoid.
Yeah, it's like if you got a complete skull of something, it's fairly obvious what group it belongs to, particularly when it's Triassic.
If Martil was involved, that might have been Dracoraptor, though, because...
Oh, yes. Yeah.
Dracoraptor is actually probably not a coelophysoid.
So now we need to know whether Dave is a genius or whether Dave misdiagnosed.
Yeah. No.
Well, if I did, I came to the same conclusion they did, because you're right. That was definitely described as a coelophysoid.
It was described as a coelophysoid. I am putting my results of my phylogenetic analysis in the chat.
Oh, look, there it is. Oh, nice. Sorry, we've just been sent, readers can't see this, but we've just been sent a little, family tree of all of them. That's amazing.
Oh, so we're selling with Lilian Sternus. Oh, so it's not too far out, because Lilian Sternus I always think of as being very necky. Now you've got me questioning, because of course what I remember is being on telly, because that was really cool. Live on BBC Two. What I don't remember is what dinosaur we were talking about. So that's far less important.
If it was Mortils, then it was Dracoraptor, which was described as a coelophysoid, but isn't.
They're quite well distributed then. I mean, and of course, for the audience, remember, this is the late Triassic. The Earth was more or less one continent at this point.
Yeah.
So getting around between very disparate points is, on the one hand, not that difficult because everything's physically connected. On the other hand, if as a group you have got USA, Argentina, Zimbabwe, China, Germany, you've got around pretty well. You have more or less got a global distribution at this point. So they clearly were a highly successful group. And at a time when, remember, dinosaurs are not very common. Dinosaurs are very much in the minority right now. If you go to big ecosystems. You know, you come back 10 million years later and anything bigger than like a dog is a dinosaur. And a few of the things smaller than that. Right now, that's not the case.
Well, keep in mind that not all coelophysoids are Triassic.
Oh, yeah, that's true.
So, coelophysoids are one of the groups that survives the Triassic-Jurassic extinction. And so you have some that are in the latest Triassic, and then in the earliest Jurassic, all the way up to the Toarcian, when there is a sort of a smaller extinction event, and that is when that group dies off.
Roughly how many million years ago is that event when they die off?
180-ish. They're around 40 million years.
Okay.
From the Norian to Toarcian, yeah.
So, yeah, I mean, in a way, that's a better... You know, the fact that they got around was one thing, but the fact that they're actually that long-lived and that they survived the extinction, because for some reason it was stuck in my head that they went at the end Triassic, but of course they don't, and I should have known that. So yeah, they're quite a successful group if, again, not presented by millions of species, but again, we're going back such a long way, they're going to be relatively few and far between. But at a time when, dinosaurs were not that common, at least initially, they've done pretty well.
Yeah. And their successors, the theropods, continue to do pretty well. People always talk about, well, in the Mesozoic, dinosaurs are more diverse than mammals. Well, guess what? They still are.
Yeah.
In just their avian form.
Yes.
Yes.
I was just clearing it up. Birds, everybody. They're talking about birds. They're being very nerdy about it.
I love birds. I go bird watching and I tell people I'm looking for dinosaurs. And then they think I'm crazy.
I tell audiences who are not there that dinosaurs are birds and birds are dinosaurs, and they look at me like I'm mad too.
It's weird though, because that's one of those things which I thought was now such a common did you know that most people knew it.
They insist that birds are descended from dinosaurs, but not actually dinosaurs.
The same thing. It's that subtle taxonomic difference. Well, at least they know that much, which is important.
I hate when people say birds are descended from dinosaurs, but they are not dinosaurs. Are you going to tell me that whales are descended from mammals, but they're not mammals?
Exactly.
They have retractable nipples. That's another fun whale fact for you.
I was going to say, if you think that's a defining mammal characteristic, I've got news, right? It's a whale characteristic.
Well, it is.
They have nipples.
They have nipples. That is a therian characteristic.
Some mammals don't, obviously. Think of the
kidneys. Monotremes
right, monotremes, which are not therians.
But anyway, okay. I feel when we get into whale nipples, we may have drifted slightly.
I'm thinking that I think we should call this
by
one
now, but...
Exploding Dinosaurs and Retractable Nipples. I think that should be the title of this episode.
I mean, it's likely to get... It's clickbaity, but it's likely to get clicks.
Okay, so they're around for 40 million years. They're everywhere. They're small, but not that small. Still 2 meters is a big thing. We've got several different species of them. We've got evidence of the fact that they go on to do other things in other areas, and we've got things that are close to them which are not them. And we know that some of them may have been, but we don't actually have direct evidence for, but there is kind of evidence they might have been cannibalistic in an extreme circumstance. But do we have anything about just the way that they were, what sort of food they would have been eating? Can you tell by their claws what they were catching? Can you tell anything about them other than we've got some? You know, what would you imagine their life was like?
So there was an ecological study that was done that compared the sclerotic rings, which are basically eye bones. That's a thing that some reptiles have.
That's that weird sort of like thing in their pupil. And it looks like when you've got the ichthyosaurs on the walls, it looks like they've drawn the eyes on. And it's like, those are real bones.
So they have those from a few coelophysoids. Comparing that one in Megapnosaurus, which is a coelophysoid from Zimbabwe, to an extant birds, it suggests it was possibly nocturnal.
Oh, cool.
So this specific coelophysoid was maybe nocturnal. We have Scott Hartman recently did a physiological modeling where he concluded they very likely had feathers just to maintain their body temperature.
Still feathers, still cool.
Yes. So we could have guessed that they had feathers because, of course, they're within the dinosaur plus pterosaur group that has ancestrally feather-like stuff. I don't care whether you want to call pterosaur floof feathers or not. I have bigger fish to fry.
I just love that you're saying that flappy flaps have floof, because Dave isn't grimacing at the very idea of me. They do have floof, I know.
They do.
Filaments. Oh,
Yeah.
floofy flappy flaps.
You studied the Chinese Anureognathans. You've seen the flappy flap floof.
Yes, but I'm at least attempting to reduce the infantilization of my podcast. You're being a bad influence on her.
No,
please
I think
please
you'll
stop.
find. I think you'll find that scientific.
Hypnofibers.
Izzy does not require
Encouragement.
encouragement. That's the word. Thank you. Yes. Discouragement is to be encouraged.
But the fact that that's a reasonable estimation, if I was to go away and draw a picture of one, certainly having them for thermal use.
If you drew one without feathers and asked me for feedback, I'd tell you to put feathers on it. And that's actually what I told the BBC for one of their documentaries. I can't remember which one.
And I was a bit of a holdout on this, so there's an illustration which I can't mention, maybe Coelophysis centric, and the illustrator's like, do you want filaments on it? And I'm like, not really, because just in my mind they don't, but I'm increasingly having to concede that they probably did. So put them on.
Yeah.
And what were they, and do we know anything about what they were hunting, what sort of size animals they were eating, anything like that?
We have one definite prey. We know that at least one specimen that ate this Hesperosuchus, which is like, imagine if a crocodile wanted to be a fox. So they're hunting smallish prey, and they have teeth. In the larger ones, the teeth are good for like grabbing and swallowing things whole. So that tells me they're grabbing maybe fish from the river or small terrestrial vertebrates like your lizards, sphenodontians, or whatever small temnospondylus, sort of proto-amphibians, salamander-like critters were around at that time.
As we said, it's a small head on a
Yes.
the animal itself is not very big, but the head itself is small, and this long neck is going to be rapid moving. So this is in no way, shape or form capable of taking even medium-sized prey, because it just doesn't have the bite power to kill it, and it doesn't have the head size to swallow it. So they're going to be, I mean, even the adults, I'm sure, would take insects and stuff.
Oh, yeah.
I happened to be reading a paper on crocodilian diets a couple of days ago, and they were doing stomach flushes, and even 2 meter long crocs, something like 10% of their consumption was insects. It's really a lot for a 2 meter croc weighs a lot more than a 2 meter coelophysoid, because it's just solid. So they're going to be
a lot of
that
carnivores
kind of stuff.
eat insects because they're everywhere and they're easy to catch.
Particularly insects that fall into the water near a crocodile.
Yeah.
Well, right, but also they can process stuff. So you think about a really armored beetle, that's very hard for something like a crow to get into, but a fox, straight down,
Exactly.
And so actually, the kind of beetles that might trundle around feeling they're largely immune, therefore actually quite easy to find, suddenly become very vulnerable.
And the interesting thing about Coelophysis' diet, and this is unpublished, but will be published very soon, hopefully, because it's in that same paper I've been
As
mentioning.
long as you're comfortable with going out to all the
Yeah,
podcast
I've already
listeners.
said this at SVP, so I think it's fine.
Okay.
The teeth are quite different in the smaller ones and the larger ones. So I think they're more like what you see on a Komodo dragon, the Zephodont teeth that are good for cutting flesh off of bones rather than for grabbing. And ecological implications of that, I don't know, but it means probably they were feeding somehow differently from the adults.
There weren't any other large creatures around at this point, I'm presuming.
Oh, there were, but they were not
Were there?
dinosaurs.
They were dinosaurs.
They were not dinosaurs. They were
Okay.
croc-line archosaurs. There is a very large croc-line archosaur from the Coelophysis quarry that is still undescribed, but it is similar to Postosuchus, which was initially interpreted as a tyrannosaur ancestor. So that kind of vibes.
Very big-headed terrestrial crocodile.
basically.
Standing upright.
Yeah.
Terrifying.
But yeah, the kind of thing which would swallow Coelophysis whole if it got hold of one.
Pretty much.
They're out there.
But also the kind of thing that if it passed away, Coelophysis could go up and rip parts off it.
Exactly.
Scavenge.
Yeah. And there's some big herbivores too. It's not just big carnivores.
Yeah.
So to sum up then, you've obviously spent a lot of time on these dinosaurs. What is it to you that you find so special about them?
I like them because they're theropods that are not big.
Nice.
And that don't have the sort of toxic masculinity associated with them that you see with tyrannosaurs or other megatheropods, or whatever you want to call that.
Please note, she means the animals, not the researchers.
No, not the researchers.
See, I like the idea that they're sort of like, they're whippish, they've got long necks, they're they're floofy.
They are
why
floofy.
Not? And we've got so many of them.
Well, that's the one thing I'd say. I've made the not entirely serious case that we should be diverting far, far, far more research into Protoceratops, and the logic is we've got loads of them. We've got absolutely loads of them.
I agree.
From like embryos up to big adults, and they're all from more or less the same time and place. And if you want to understand growth and variation and development and changes and what a population looks like and population structure, you need something like this. And yet, other than me, and even I haven't done much in the last 4 or 5 years, no one's really doing very much on Protoceratops. And Coelophysis is the same thing. Like, the fact that we've got this many specimens, and it took Colbert like 30 years to get round to doing a monograph on it, and that was the last time anyone, well, Sterling Nesbitt did a whole bunch of stuff for his PhD, but, we have not had recapitulations of those studies going through specimen by specimen and detail by detail. We should. These are such a rarity for this kind of data.
This is something that I am hoping to do, and I have been trying to convince people to do, and other people seem on board, but it's a lot of work, so it's going to take years and years for it to happen.
There are several members of the younger generation, Generation Alpha, listen to this podcast. Don't listen to your parents. Don't try and get a decent job with lots of pay and everything else. Just go to New Mexico and start digging. And really just, we need the specimens, we need them measured, we need all of the numbers, please.
Or go to museums and start preparing the fossils that have already been dug up, because there are so many that are just in the basement of the museum.
Get to love lists now and making them, and you will be happy forever. If you want to, jigsaw puzzles with bits missing, that's, train now.
Anyways, I hate so puzzles, but...
But thank you so much for coming on. Where can people find you on the internet and stuff if they want to ask you a question or say hey?
Twitter is dying, but I'm still on there at Skye McDavid, SKYE McDavid. People always forget there's an E in my name. Otherwise, you can just Google me and you'll find my website and other socials.
Excellent. Well,
thank you for
so
having
much
me.
For coming on. It was really cool, so thank you. That was an awesome interview. Well done for tolerating all the flappy flaps, Dave, and not completely losing your cool, because they will stick in the edit. I promise you that.
Right.
But Coelophysis, who knew that? I mean, there's so much that we sort of got into there, so I'm really pleased. And also, Coelophysis is one of the groupings that you can be if you join our Patreon. Not saying that you have to do that, but thank you very much to all the patrons who do that. You will be getting a questions episode that Dave and I are about to record after this one, so it's very exciting.
I think it's all very clear. Coelophysis is one of those things that we should be doing much more on, and it's a shame that we're not, and it's great that she and her colleagues are, because it is an iconic animal, but also has that depth of data that we should be mining much better. But having all those things laid out, like, have we got males and females? Have we got juveniles and adults? Are there some cryptic species in there? Is kind of fundamental to doing any of this other stuff. So yeah, the more and more we do for that, of course, it kind of self-fulfills and gets bigger and bigger and better. So hopefully that's the step on the path to further Coelophysis greatness.
Once again, we're going to plead with all the PhD students out there to please do their PhDs, which will involve chipping away at a lot of rock and getting out all of these fossils, which will take forever, and then cataloguing them. That'd be awesome. Well done, you. Thank you for doing all that hard work. Anyway, Dave, We should, I mean, Coelophysis, it probably roared, didn't it? It's probably a big growler.
I mean, roar is strong for an animal that's, what, 10, 12 kilos?
Well, I don't know. I mean, my cat can make a funny noise occasionally, particularly when it's about to be sick. So why don't I do that sort of noise? So, until next time, everybody, 1, 2, 3.
These are definitely getting worse.
Thank you for listening to this episode of Terrible Lizards. You are amazing. If you're a patron, you're double amazing. You can support the show by going to patreon.com/Terrible Lizards, or just go to terriblelizards.co.uk and follow the links. If a bunch of extra content and having your questions answered doesn't appeal, you can always support the show by leaving us a review. Please do share it with your friends. It does make a massive difference. And if you want to support either Dave or myself individually, please go to our respective websites, davehone.co.uk or iszi.com. You can get our books. Mine have got nothing to do with dinosaurs. But anyway, squawky bye-bye.